So this is part 3 of the Python Playground program I built. So again, what we have is we have a program, super simple Python program. It's got 10 million long vector of inputs, no file access, no nothing else. Basically, it's got 3 parameters. So 10 million long vector that's 3 wide. And it will, the program, all it does is takes the 3 numbers, calculates the logs of them, and multiplies them together. Right? So it's log A, log B, log C times each other. That actually gets put into a 10 million long vector to return the results. So we generate 30, we have 30 million pieces of input data, and we get 10 million pieces output data back. So talked about this a little bit before. This time it's the DASK version. So the DASK version in some ways is like the GPU one, and other ways not at all. So for DASK, so for the GPU, what we're going to do is we calculated, we got 10 million, and we figure out how many tasks we're going to put into the GPU, and we feed it to the 2,000 CPUs in my GPU. For DASK, we're going to do it a little different. What we're going to do, we have 10 million, but we really only have so many DASK worker threads that are available to us, right? We either have remote machines in the cloud or on my machine here. I'm going to use my, I got 2 Xeons, right? And so that gives me 32 threads. So I've got 16 cores, 32 threads. What I'm going to do is I'm going to take the 10 million, I'm going to generate 32 threads worth of distributed work, or workers, right? And then we're going to take the 10 million and we're going to divide it by 30, or 32, and we're going to feed that number, 1/30th basically, a little less, of the 10 million to each of the nodes, and then each of the nodes is going to loop across that, right? So we're going to use conventional CPUs, and we're going to try and parallelize this by pushing it out to the worker threads. So if I had a server farm like in the cloud, I could take this, push it all the way out, and then bring it back. What's the downside of this? The downside is it takes a long time to push this into the other processes. Now, DASK actually has a way to do this inside in your thread pool, which is great, although really, in that case, it might work better to just see if you can get the JIT to parallelize it. But it gives you a good way to test this. And then if you have lots of machines, you push it out. But network is really slow, so you got to have a lot of computation or a lot of input files, right? Like where you're I/O bound, so that you want to push this off to different machines. But we'll do this program anyway, just as a demo. So what's going to happen? The driver is going to calculate the number of execution tasks, my driver. This is my program. And it's going to split the data by task. So we're going to take the 10 million and make 30 arrays of 10 million divided by 30. What is that? 1 million, 300,000 a piece, right? And then we're going to scatter the subsets across the cluster. So we take 10 million, we put it into 30 arrays, and then we scatter that across the cluster. That basically puts 1 array in each of the worker nodes, right? And then we invoke the calculate function across all those nodes, and they will each operate against their subset of the data. Inside the worker thread, I just have a simple program that iterates across the 300,000 or however many it gets and does the calculation. And then we collect the results from those 30 nodes or however many worker threads we have, because we have some cases where we only ran it across 1. We calculate those results and we create an aggregated array. And then I just sum them to prove that I got the right answer back. Okay? So on the main CPU, we're going to do these things. On each of the worker nodes, they're going to receive the data, and then they're going to get the function called on them. They're going to iterate across the data and generate the results. And then the main CPU is going to get the results back from the remote CPUs, right? So, I shrunk my text again, so we're going to make this a little bigger. Well, that's not too big. You can still see something. And I'm going to go down here, and we're going to pull up the DASK demo. So the DASK demo, really, we have one function that calculates the number of worker threads, right? So when you create a DASK cluster, DASK will automatically create a supervisor node, a scheduler node, and a bunch of worker nodes, the number you ask, or the number based on the number of cores and threads, hyperthreads that are available, or the number that's available in your remote cluster. So you can actually ask the client how many workers there are. So we're going to actually calculate the thread count. And in this case, what I do is I find the number of worker nodes, and then I get the number of threads on that worker node, and I just assume they're all the same. Because in my case, they will be. My cluster all has the same number of threads on each worker node. You could do it a little differently. So we're just going to calculate the total worker count, right? So if we look at what the driver does, the driver calculates the number of DASK task nodes, the tasks that are available to us. That makes sense. We could create 10 million tasks, but it would do 10 million pushes through the scheduler. It's like a horrible idea. What we kind of need to do is optimize the number of tasks against the number of task nodes and the amount of work we got to do. So there's a little bit of math involved there. So we're going to calculate the number of DASK tasks. Then we split the input array into that number, right? So now we have a list of lists. We have a list of arrays here, list of arrays. And so it needs to be a list because the way the map function works to send it out, you got to use a list. So I have a list of input arrays. Then we scatter those and we get a future back. And that's, so those things will be asynchronously pushed out to the nodes. And the other advantage of this, doing the scatter, it actually goes to the worker nodes. If we pass the whole array to all of these and they work on a subset of it, that's all got to go through the scheduler node. We don't want to have that happen. So this distributes it out. And then we map the function, right? So in this case, we're going to map this one here. And I'll show you what it is in a minute. So what we do is we take the input array, we divide it by the number of tasks we have, we push them out, and then we invoke a function using the scattered data future, right? And that'll actually give us a calculated future. And that thing will go and execute, and we can either pull it, or in this case, I just did a synchronous call. I said, gather the results. That really means wait until all the tasks are done and bring it back. We wouldn't have to do that, right? We could map out multiple functions, and that would make sense. It was expensive to put it out there. So if I wanted to map this thing and do it multiple times or iterate or do something else, we could gather the result at the end of that. And then so this just says, wait, send, when the calculated futures are complete, then we're going to gather the results. We're going to put it back. That's all we do. So the two things that are important here, right? So we push, each of the worker nodes basically acts as its own calculation engine. And it's each got an array, right? And then we got to get all those answers back. So if you think about it that way, we have to set up we have to calculate how many we're going to do on our node, on the node itself, on the worker node. And then we have to create a result array, right? And then we actually calculate using the normal calculate function. So we have a calculate function we used in the regular calc core, which is just log A times log B times log C, and it returns it. So we're going to use the same normal math function. So the actual calculator we used in the GPU and in the CPU and in this all really are kind of the same function. So the driver, we pushed all the data out there. We invoke the node driver out on the worker node. That calculates the number we're going to generate. It builds the result array, and then it returns it, right? So that'll actually get mapped to the return future that we did in the map call. And that's all there is to it. We have this calculation function that got pushed out there. We have this JIT serial one out there. That one's actually going to loop on it and make it happen, right? And I didn't make it parallel. You can actually make this go faster parallel on a local machine. So I could create task nodes on my local box, and we know there's going to be wait and scheduling and all kinds of other problems. So the way I did this is I just made it a serial thing on each of the task nodes. Calculate your 10 million divided by 32, right? But you could actually make that one parallel too, and then the machine will try and jack the CPU way up, right? Because you'll have a bunch of task nodes running on those machines, and they'll all be executing in parallel. You got to be careful because there's a balancing act there, but it's really up to you, and that's really all there is to it. If we run this, oh, you know what? I'll cheat. We'll just do it like this. And if we do F5. All right, so you can see here, big. Sorry about the wrap. Oh, you know what? I got more screen here than I'm using. Let's just do this. right? So here we can see we have one process with 32 threads. So we're gonna have 32 threads. We did 10 million iterations. It took 2 point. So this one's multi-threaded. It actually set up the worker nodes all as threads. It's kind of weird. I don't know why this one's always the slowest. If you do it as a single thread, it took this long, right? So we actually only did one worker thread. If you look, this will, because it's JITted, it'll actually be about the same time as the JIT serial, right? And that makes sense. So we have a JIT serial. We're doing DASK in worker threads rather than external processes, and we only had one worker thread, so it runs about the same as the JIT serial time. And then we have process multi, and then we have process single. And the single one, I think, I don't know why that one's the slowest. I'm guessing because it's got to copy the data out and copy it back from another process, right? And it's single threaded, so it's got to be slower than single threaded local because it's single threaded distributed. So that's really it. It's kind of interesting to play with all of these. The math functions are the same. The way you do the loops are a little different, especially for the GPU one. But really, the DASK one just runs the single-threaded version on multiple nodes with subsets of the data. So here we have a simple program that shows how to run it basically 5 different ways for different kinds of performance. And in your case, you'll just have to figure out what's the best one. Obviously, the JIT is the simplest. But if you have lots of input files, you're going to pick one of the distributed versions, probably DASK maybe. And so that's it.